Welcome to our deep dive into the fascinating world of language models, particularly focusing on techniques for constrained text generation, optimizing model outputs, and the hardware requirements for running large AI models. We'll also explore the capabilities and limitations of models like ChatGPT. Let's get started. Constrained text generation is a technique used to guide language models to produce text that adheres to specific rules or constraints. This is particularly useful in applications like poetry, where you might need to ensure a certain syllable count or rhyme scheme. One effective method for achieving this is through constrained beam search. This technique, available in libraries like Hugging Face, allows you to filter tokens according to predefined constraints before generating text. For example, if you're generating a haiku, you can set constraints to ensure the 575 syllable structure is maintained. Another approach involves using sampling techniques such as top K, temperature, and repetition penalties. These parameters help control the randomness and diversity of the generated text. For instance, setting a high top K value allows the model to consider a larger set of possible next words, making the output more diverse. Conversely, a lower temperature value makes the model's predictions more deterministic, producing more focused and coherent text. To optimize the outputs of language models, it's crucial to fine-tune these parameters. For example, setting top K to 40 and temperature to zero point 0.7 can significantly improve the quality of the generated text. Additionally, repetition penalties can be applied to discourage the model from repeating the same phrases, making the output more varied and interesting. Another powerful technique is few-shot learning, where you provide the model with a few examples of the desired output. This helps the model better understand its role and produce more accurate responses. For instance, if you're training a model to answer customer service queries, providing a few examples of questions and answers can help the model generate more relevant and accurate responses. Despite these techniques, users often express frustration with the default samplers provided by some models, describing them as producing subpar outputs. This is where reinforcement learning from human feedback, RLHF, comes into play. RLHF fine-tunes models based on human feedback, making them more useful and less disappointing for users. For example, if a model frequently generates incorrect information, human feedback can be used to adjust its parameters and improve its accuracy. For those interested in diving deeper, there are numerous academic papers and resources available. For example, research on palindrome generation and work from Sony CSL on constrained sequence generation offer valuable insights into advanced techniques for constrained text generation. These papers provide a theoretical foundation and practical applications, making them essential reading for anyone looking to optimize language models. Running large AI models like ChatGPT requires significant computational resources. While high-end MacBooks with unified memory architecture can be an option, they are not the only solution. A more cost-effective approach is to use a vanilla Ubuntu desktop with a used server-grade NVIDIA GPU that has a lot of GPU RAM. For instance, a 16GB M1 Mac Mini can successfully run a 7B model, making it a viable alternative for those on a budget. The unified memory architecture of Macs allows for up to 96GB of VRAM on a laptop, which is unique and beneficial for running large models. However, the future might involve more tightly integrated CPU, GPU, and RAM systems. This architecture, where the GPU is part of the CPU and there is no separate CPU RAM and GPU RAM, could be the inevitable final solution. Many users express frustration with NVIDIA's reluctance to increase RAM on their GPUs. For example, the highest-end consumer GPU, the RTX 4090 Ti, has only 24GB of RAM, whereas researchers expected at least 64GB. The potential of 3D chip technology is also discussed, which could offer massive cache and integrated GPU and CPU cores. However, there is concern that NVIDIA might not support this direction, creating tension in the market that could be detrimental to end users. ChatGPT and other large language models have impressive capabilities, but also significant limitations. While they can generate novel sentences and ideas, their knowledge is limited to their training data, often leading to hallucinations or inaccurate information on niche topics. For example, ChatGPT might generate a plausible but incorrect answer when asked about a specific historical event. There is ongoing debate about whether ChatGPT can produce genuinely novel ideas. Some argue that it can, citing examples like the creation of the game Complete, while others contend that any perceived novelty is just a rearrangement of existing information. The concept of chain of thought, C, and iterative processes could enhance the model's problem-solving abilities, making it more capable of generating novel ideas. Future improvements in language models may involve architectural changes, such as incorporating memory mechanisms, iterative loops, and metamodels to enhance abstraction and problem-solving capabilities. For instance, using multiple medium-sized models in a meta-network could achieve more sophisticated and nuanced outputs. Some researchers draw parallels between human thought processes and the potential for language models to iterate and refine their outputs. With the right architectural enhancements, language models could develop more human-like reasoning, making them more effective in various applications. In summary, the world of language models is rich with potential and challenges. Techniques like constrained text generation, few-shot learning, and RLHF can significantly improve model outputs. However, running these models requires substantial hardware resources, and current offerings, particularly from NVIDIA, may not fully meet the needs of AI researchers. While models like ChatGPT have impressive capabilities, they also have significant limitations that need to be addressed through ongoing research and development. By understanding these techniques and challenges, we can better harness the power of language models to create more accurate, useful, and innovative applications.